Hey guys, it's John. This is lab number three, black hole and spaceship problem for physics. So a quick introduction. This lab had two parts. The first part we used glow strip to make a like a planet or a star orbit around a black hole to estimate the black hole's mass. And then the second part we used glow strip to model how a spaceship taking off the moon's surface would orbit by a star and a moon. And we found like the initial velocity to create a desired orbit. So we use Newton's second law, like the momentum principle, and the different the main gravitational force of gravity, and then also position and velocity update formulas and like net force. This also used Fnet and like Fnet equals dp/dt, or like the rate of change of momentum over time. And we use this in both the parallel and perpendicular directions. And so, like I said, force of gravity, gravitational, negative g m1 m2 divided by r squared, and then our position and velocity update functions. And then, so our first part, I'll show you. Um, we can run the program so it goes around. And basically, these are just different values that it's estimating the mass to be at the different time instances in the orbit. And then we can see that the average mass of the black hole, which is our estimation, is 1.346 about e to the 34. So very, very large mass. Yeah. And then our second part, so this is the final orbit that I got. I'll run it here for a second, but this is the initial velocity that I found to make this orbit work. And as you can see by kind of like the irregular orbit, is that it was influenced by both the moon and the planet. So I can run this for you guys for a little bit. So it kind of starts out like that, but it's constantly being kind of manipulated by the moon, while it maintains a strong gravitational pull to the sun or the star at the center. I'll let it run for a little bit longer, and then show you the code. So pretty cool, kind of cool to see how like the different orbits change with where different like masses in the as the radius has changed. So I thought that was pretty cool. So in my code, we did a lot of editing. For me to kind of change the velocity and have different like uh, changers of the velocity. I used a scalar on the front, a small kind of velocity changer, like a small scale velocity changer, um, inside of the like that's subtracted out from the exit velocity. So and then I also multiplied it by cosine and sine, theta and phi, where I could just determine what degree off of the moon I wanted it to launch off of. So a little complicated there. And then all these were changed to change the position and the force, and then same for these. And then I can go back and show this code as well. Not too many changes are made here, like put in my email and stuff like that, and then um, edited these to find the different like stuff that we were looking for FNet perp, DPD, the different changes in momentum. So what does it mean? The values of net force in the parallel and perpendicular components, they're the same value, whether it's net force or change in like the change in momentum. Um, but they're found differently. Obviously, the net force is the sum of the forces acting on that object, and then the change in momentum is found based on the change in velocity times the mass divided by the change in time. So mass is constant, so it's just analyzing at different time periods what is the different velocity. And then what if we wanted to measure the momentum or the motion of the black hole and star combined? Um, we would just have to understand what the forces that are acting on that as a system are, whether it be The intersystem force that the star, the intersystem force of gravity that the star impacts on the black hole or other celestial bodies in the area. Thanks.